Welcome to today's Explainer. We're diving straight into the explosive rise of AI research startups, what we call neolabs. These organizations are completely rewriting the institution of innovation. Why? Because in many AI domains, the research artifact, whether that's a model, a proof system, a robot policy, or a code agent, is already a production artifact moving directly toward infrastructure. That makes these labs incredibly powerful, but also incredibly fragile. So how do they keep from flying apart under all that pressure? Well, we're going to break down a framework called the energetic paradigm, or EP, which reveals exactly how these unique institutions operate as research production engines.
So here's the multi-billion-dollar question, isn't it? We see this massive influx of capital pouring into the AI space. We've got reports of private valuations soaring, like safe superintelligence at a reported $32 billion. But we really have to ask ourselves, is this incredible momentum translating into actual verified progress, or is it just a lot of very expensive noise? High valuations buy time, compute, and the ability to recruit absolute top-tier talent, but they do not automatically create scientific direction. In fact, that same capital can actively distort the science if a lab starts chasing brand hype before they have real causal evidence.
Right now, we're watching a massive shift in where control actually sits in the AI economy. Labs are staking their claims across some wildly different domains. You've got companies focusing on the physical economy and engineering, like skilled AI and physical intelligence. You have those tackling scientific production, like isomorphic labs and drug discovery. And others, like Harmonic, are focusing entirely on formal mathematical reasoning. But the shared ambition across all of these is that these labs are trying to own the foundational platform layers of entirely new industries, often way before a mature, consumer-ready product even exists.
To really wrap our heads around how they achieve this, it helps to think of a neolab like a giant reactor. The raw inputs going into this reactor are capital, compute, elite talent, data, and market expectations. Under the energetic paradigm, these inputs are viewed strictly as stored energy, not actual progress. The EP framework doesn't replace these inputs. It organizes them, so the lab can actually distinguish real progress from mere motion. If a lab is just burning through cash, spinning up thousands of GPUs, and hiring researchers without converting that energy into verified results, they aren't progressing. They're literally just becoming more expensive.
Here is our blueprint for this explainer. 1. The rise of neolabs. 2. Causal paths over narrative. 3. The 5 conversion gates. 4. Governing recursive feedback loops. 5. Resources, uncertainty, and time. And 6. Safety as operational control. Section 1. The rise of neolabs.
What exactly makes a neolab fundamentally different from an ordinary academic laboratory or a traditional Silicon Valley startup? It basically comes down to a single radical shift. In earlier scientific revolutions, the distance from a theoretical discovery to a commercial product was incredibly long. It took years, sometimes decades. But in the AI era, a research result, like a model checkpoint, a drug design engine, or a code agent, is often already executable. The research artifact is the production artifact. This compresses science, engineering, capital, safety, narrative, and market timing all into one highly pressurized organization. That compression creates enormous leverage, for sure, but it also skyrockets the pressure, making the organization itself incredibly fragile.
Section 2. Causal paths over narrative.
A neolab basically has two completely different roads it can travel. The narrative path is dangerously tempting. It starts with an impressive thesis, which leads to a high valuation, which generates intense media attention, which then creates immense pressure to produce a flashy, staged demo. The alternative, the causal path, is much more disciplined. It demands that a lab step back and ask, what bottleneck does this actually remove? What capability becomes possible only if this works? What evidence would falsify this path early? And which experiments reduce uncertainty the most per unit of compute? A strong neolab has to honestly know which path it's on. It's the difference between chasing publicity artifacts and creating real conversion products.
Section 3. The 5 conversion gates.
To prevent a lab from just being a prestige vessel, the energetic paradigm outlines 5 strict conversion gates that are much stronger than ordinary startup milestones. First, mechanism. Does the system actually show why the claimed effect occurs? Second, transfer. Does the capability survive outside a narrow, controlled demo environment? Third, cost. Does it reduce the total cost of search, testing, deployment, or design? Fourth, control. Does the system remain diagnosable when it's scaled up or connected to tools, robots, or live markets? And finally, adoption. Can a real institution integrate this without having to rebuild its entire workflow? If a lab's outputs can't pass these gates, they simply aren't executing.
Section 4. Governing recursive feedback loops.
We are seeing a lot of NeoLab directions relying heavily on recursive loops. AI designing better chips to train better AI. Agents generating data for future agents. Robots learning continuously from deployment, and formal proof systems verifying their own reasoning. Now, these loops are incredible because they compound progress. But without strict governance, they can just as easily compound errors, hidden incentives, and wildly unsafe shortcuts.
Positive feedback is not automatically a good thing. It has to be strictly governed. Any recursive loop needs 4 specific safety devices in place. There must be verification. There must be damping to slow down runaway processes. There must be a rollback mechanism if things veer off course. And there must be external constraints. The golden EP rule here is that recursive improvement is acceptable only when each cycle improves a verified causal state, not merely an internal, gamified metric.
Section 5. Resources, uncertainty, and time.
Think of a lab's resources as 3 critical meters on a dashboard. You have talent, which isn't just a head count, it's directed cognitive energy. You have capital, which isn't just validation from investors, it's stored optionality. And you have time, which is the medium in which scientific uncertainty must be reduced. Elite researchers will absolutely leave if they don't see a clear path. Investors might demand premature milestones, and leadership can easily fall into the trap of defending their valuation instead of discovering the truth. Managing these 3 meters is a core part of the lab's overall control architecture.
This quote right here perfectly hits the nail on the head. If talent, capital, and time are moving, but scientific uncertainty isn't going down, a giant warning light should be flashing. Runway is not progress. Energy is being consumed without convergence. Spending capital and burning through cognitive energy without moving closer to a stable, verified output is the hallmark of a failing control system.
Section 6. Safety as operational control.
Safety should never just be treated as branding or a separate ethics document sitting in a drawer somewhere. It must be a structural, operational control loop. For robotics, safety means physical action recovery and human overrides. In biodesign, it means rigorous control over off-target effects and clinical translation. For code agents, it involves strict permissions, tests, and production boundaries. For formal reasoning, it requires proof validity, and for superintelligence, it demands absolute control over goals, tool access, and deception. The reality is, a lab that cannot diagnose its own failure modes cannot safely scale its capability. No exceptions.
Zooming out, what is the actual intended endgame here? After passing through all those control layers, causal paths, and conversion gates, the outputs shouldn't just be hype. The goal is to move from impressive papers and staged demos to mature platform adoption, verified transfer, and stable revenue. The whole point of the energetic paradigm is to organize a lab so it can actually distinguish real progress from mere motion and real platform formation from narrative inflation. Which leaves us with this final, incredibly provocative thought. The world isn't going to be shaped by whichever NeoLab manages to raise the most money or hire the most famous researchers. It's going to be shaped by the labs that can maintain rigorous, causal discipline when the pressure is at its absolute highest. Whether you're investing in, working for, or eventually relying on these new AI institutions, you have to ask, are they just a speculative research brand, or are they a truly governed execution machine? Thanks for joining me on this explainer. It's a lot to think about, and it fundamentally changes how we view the future of AI innovation. Keep questioning and keep learning.